Hi, everyone. I'm going to go over how to process your data for the Weir lab. What I have here is a table of the data that we've collected for V-notch Weir. We have H, which is the height of the water above the notch in the Weir, the V-notch. So the height above that elevation, the bottom of the V-notch. So presumably you measure that height on the flume, and then you measure the water surface just behind it, just upstream of it, to get your H value. So here are those data, and it ranges from about 9 millimeters to about 20 millimeters of water above the bottom of the notch. And then we've transformed that based on H to the 5 halves. So here's our Weir equation for the V-notch Weir, and it's C is equal to, or Q is equal to C times tangent theta over 2 H to the 2.5, or 5 halves. So by transforming the data to the 5 halves, it should plot relatively linear for us. And then if we fit a linear line to that using linear regression, then the slope of this line should give us this Weir coefficient. So that's what we're doing here. So I've plotted these data, and notice that I have H to the 5 halves on the x-axis. That then gives us the slope. So that's basically the same form of this. H to the 5 halves is our independent variable, and then the slope will then be this term right here, C tangent theta over 2. So in my version of Excel, I click on the data points, I right click, and I add trend line. I think you can also go to chart design, add chart element, and do trend line over here. So we're going to do linear trend line. And then I'm going to click on that. And over here in my options, I'm going to set the intercept to 0, because 0 flow should be 0 head, and then display equation on chart. I'm just going to rewrite this so you can understand what it actually is. This is Q, and then our X is H to the 5 halves, or 2.5. All right, so now that we've done that, we've got this value. And to calculate C, the actual coefficient, we're going to say C tangent theta over 2 is equal to that value, 1.0332. So then you can calculate C from that directly. You can also calculate C individually for each of these measurements based on your Q and your H. And I think I asked you to do that as well in the lab. All right, now that we've come up with our Weir coefficient, we now have a calibrated Weir equation, or rating curve. Another name for this is a rating curve. So I'm going to come over here where I've plotted this. And what I did is I just created a vector of H spanning the range of our data. So I just did 1, 2, and then double click that, and it propagates down. Here, I've put in our rating curve, or Weir equation. Those are synonymous. And I didn't calculate C here directly. I just put in that value times H to the 2.5. So that gives me my Q value as a function of H. And then I can hover over that little box right there, double click, and it propagates the equation down. I'll just show you if you haven't seen that before. The other thing I ask you to do is plot a published rating curve. If you use the kind of the big V-notch one, it might not have a specific published value for a Weir coefficient there in your textbook or the USBR manual. So I'm just using this equation. This is the USBR standard V-notch Weir equation. It's a little bit different, but close enough. So I put it in there, 1.34 times H to the 2.48. In this particular case, the units for this Weir equation are meters and cubic meters per second. So that tracks. So type that equation in, and I'll just show you that I can propagate it down by double clicking on that little square. All right, so let's add those time series. You'll notice that I flipped the X and Y axes here. This is the standard way of showing Weir equations and rating curves. Q is on the Y-axis. Or sorry, I didn't update this. This is H is on the Y-axis and Q is on the X-axis. Okay, And what it's just showing is that as you go up in height, here's the trend in discharge. So I flipped those two axes from before. In my version, I'm going to, let's see, I'm going to add a new data series. I think I need to do it by right-clicking here. I can go up to select data, or I can right-click on the chart. I'm going to edit this one. I'm going to call this the experimental rating curve. And then I'm going to add a new data series. I'm going to call this one the published rating curve. My X data are going to be these. My Y data are going to be here. And I can click on that first cell and do Control Shift down, and it will select all the contents in that vector. Control Shift down. All right. Oh, I didn't get sorry, my X data should be flipped here. So my X data is Q, and then my Y data is H. Let's just make sure we did that correctly. There we go. Okay, so now we have the rating curve. You can see it doesn't line up super well. That's fine. It wasn't supposed to be, but that's the only published one we have for this. And then finally, I'm going to add my data points. So these are going to be data. Okay, my X values in this case will be Q, cubic meters per second. And then my Y values will be H. So those are my 3 data series. And it's plotting it as a line. So I'm going to click on that. And then over here, format data series, I'm going to say no line, and then markers, marker options, automatic. And we'll just make those black. How's that sound? So obviously our calibrated Weir equation fits those data pretty well. The published one doesn't. And then I'll add a legend here. So let's just go to chart design, add chart element legend. Put it on the bottom. And there we have our experimental rating curve, published rating curve, and then our data. So that is what we're trying to do for this particular part of the lab.